Okay, so today we will be on, I think we finished the recursion, right? So today we'll be on sorting and searching algorithms. Okay, and swapping, we also on swapping. So we'll discuss some linear structures algorithm. Okay, on this one. Okay, let's get started. Okay, first thing is, let's get started. Okay, first thing is you must know about these different algorithms. All of these algorithms, you must remember them by heart. Okay? You must remember them by heart. You must remember every single step. So first is a swap. Okay? Swap, we have swap, shifting, and rotate. Okay. So first thing, you have two ways you can do swapping. Swapping, you assign. You can use a rotational swap. So left-hand side is a rotational swap. Say we have a data that's A, let's assume that A is 3, B is 4. We want to do swapping. You must back up A to a temp value and then copy your B's value to A, okay? And then copy the backup value from A to B value. Okay, I'm sorry, here you change it to 4. Here you change it to 3. So you will swap, okay? Let's do swapping. It's called a rotational swap, okay? It looks like a rotation. It looks like a rotation. So one more time. First, your data may be 3, okay? In A and B, it's actually 4. You back up your A's value to 10, so it becomes 3 in 10. Okay, after that, you actually copy your B to your A, so A becomes 4. Okay, and then you copy 10 to B, so it becomes 3. So then your 3 and 4 got swapped. Okay, A and B got swapped. That's one way you do swapping. Second way you can do swapping is you can actually copy A to temporary buffer A. Okay, copy B to buffer B, and then you copy buffer A to B. Okay, and then you cover buffer B to A, and this using the swapping network. Okay, either way will work. Okay, but it doesn't work this way. Okay, it doesn't work this way. You have A. Okay. And B, you try to swap, but you assign A to B, okay, and then actually B to A, okay. This doesn't work, okay. This doesn't work because when you copy A to B, your B already contains the A's content, so B copy back to A, then A still be A's value, okay. So it doesn't swap that way. So this swap is very important because in many sorting algorithms, it actually swapping base. It actually swapping base. Okay, so this swap is the very important calculation. Okay, so second we have shifting of the element. Okay, shifting of the element. Let's assume that we try to shift the whole array to the left. Okay, to the left. So we have array. We have 1, 2, 3, 4. We try to shift it to the left. Okay, index is 1, 2, 3. So the way to do is that I pick up the index 0's location's value to 10 value, right? And then I copy number 1 to 0 location, index 2's value to 1's location, index 3's value to 2's location, and then temporary value copy to here. So something like this. Okay, so something like this. Let's assume that my initial value is actually A, B, C, D. So I pick up A to here, and then B copy to here, C copy to here, D copy to here, and eventually copy temporary value back to here. So it becomes a rotation, okay? So call is on this side here. Okay? It pick up your index 0's location to a temporary value. And then from I equals 1 to the end of the string, that means that you're starting from this one, copy to the left, copy to the left, shifting to the left, shifting to the left, shifting to the left, until the last one. Okay. After that, your temporary value copy back to the last element. Okay, that's the last element. So this one's left shifting. Right shifting is similar. Right shifting, you back up your last element to a temporary value. Okay. last value to the temporary value. Then you copy the one next to the last one to the right, to the right, to the right, to the right, and the last one from index 0 to index 1. And then finally, you back a value back to the index 0 location. So this one's shifting to the right. Okay, this one's shifting to the right. Okay, so this is a different shifting. We finish it. Okay, this one we don't demonstrate how to write it because they are very simple. This one, linear search. Linear search is also called the sequential search. Okay, so you are given an array or array list. You pass the key into here, so you traverse to each of the element in the array or array list, and then when there's a hit, you return the index. Otherwise, you return minus one. So this one is called linear search. Okay, linear search. Okay, now linear search. Next one, we'll go into the binary search. But before we do binary search, let's look into some index scheme. Okay, index scheme. So because we want to look into the index scheme, let's look at the reverse of a string. Okay? If we need to do reverse of a string, if we need to do reverse of a string, how can we handle the reverse of a string? Okay. Okay, here I'm going to create another with A, okay? Okay, first one will be reverse of string. Okay, this one is the reverse of a string, okay? We may already visit this one, okay? We may already visit this one, but the purpose of this one is we'll return a new a string, okay? That will be the reverse of another string, okay? So let's assume that we have a string, and we get that we would create a new string, okay? So this is a new string, let's call it a reverse string, okay? So this reverse string will be empty, okay? And then at the very end, we return this string. So now let's assume that I get a, B, C, D, E. Okay, so I would like to reverse it. Okay, I would like to reverse it. So okay, so basically one way I can do it is actually I can do swap. Okay, now let's do this one. Okay, let's actually do change it to reverse of a integer array, okay, instead of using the string. Okay. I'm sorry. So let's actually use the this one. Okay. Okay. Let's assume that we actually try to reverse the integer array, not a string. Okay. So here, for example, I have an array of integer that's 1, 2, 3, 4, 5. I want to reverse it. Okay. I want to reverse it. So first thing is that you need to calculate your symmetry location. Okay. So here the index is 0, 1, 2, 3, 4. Okay. The index is 0, 1, 2, 3, 4. So you need to do reverse of the string, reverse of the array. You need to swap these two numbers. Okay. You need to swap these two numbers, so it becomes 5, 1. Okay. You need to swap these two numbers, and it becomes 4 and 2. Okay, and you have 3. So first one is that you need to know about your symmetry location in the array. Okay. So here this one is 0, and this index right here would be okay. Would be your length of the array is n. Okay, n equals 5. Okay, n equals 5. So this location is n minus 1. Okay, the length minus 1 minus 0. So here is minus 0. This is 0. This one is minus 0. Okay. So n minus 1 minus 0. So this one is n minus 1 minus 0. This one will be n minus 1 minus 1. Here is 1. So these are two's symmetry location is n minus 1 minus 2. Okay, and n is 5, so you actually is still getting to each cell. Okay, still getting to each cell. So remember your i's location, symmetry location would be n minus 1 minus I. Okay, that's the formula. No matter what length of the array is. Okay, so here let's assume that we have an array A will be equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, for example, like this. And we are going to reverse it. Okay, we are going to reverse it. So we will do this one. For integer I equals 0, I less than A the length divided by 2. Okay, A the length divided by 2 because you cannot overswap. So basically, you have 1, 2, 3, 4, 5. You swap this 2, okay, it becomes 5, 1, 2, 3, 4. Then you swap this 2, it becomes 5, 4, 3, 2, 1. So then you have 3 swap to each cell. Now this is okay, but you cannot continue to swap. If you continue to swap, this 2 will be swapped back to 2, 4. Then that's wrong. So you can only go half from here to here. That's actually okay. So 5 divided by 2 would be equals 3, equal 2. Okay, so 0, 1, 2, up to this element, that is okay. Okay, so need to be stopped over there. Okay, you need to stop over there. And then your I will increase. Okay, and every time you need to do swapping. So now you have your index I location, need to swap with your length n minus 1 minus I location. These two elements need to be swapped. So you have the integer temp equals A's I's location. Okay, A's I's location will be equals A's A dot length minus 1 minus I. That's your symmetry location, okay, in the array. A's A dot length minus 1 minus I will be equals 10. Okay, that will complete your swapping between these two numbers. And at the very end, you return your A's array. Okay. So that will finish your reversal of the array. So here we do import java.util. This one is the reverse of the array. Okay, we reverse A and we will print it. Okay. I'm sorry, this one you cannot directly print it. You still need to use arrays to convert an array to a string. Okay, and string we will actually print it. Okay. Okay, so that will be the reverse of it. Any questions so far for this reverse of an array? Any questions so far? Hello, any question? Hear me?
No questions from me.
No question, okay. I'm going to post the code to the chat box, okay? So in case that you are interested, you can download it, okay? So I post code, every single one after I explain it and coding it, I'm going to send it to there, okay? So this one explain to you how to use the swapping, okay? Swapping is like this. You have two numbers you want to do swap. You create integer temp equals A, okay? So A assigned to temp. Then A copy B to A, and then B copy from temp, okay? Copy from temp. So this one is you back up A to temp. Okay, you copy your B spreading to A, and then temp to B. Okay, it's called rotational swap. So we use a rotational swap in this reverse function. Okay, that's called reverse. So we finish the reverse. Okay, okay, that's actually the reverse of an array, and we use that to explain the so-called swap. How to use a swap. Okay, so many computation actually based on swap. So we did that. Linear search, we finished that. Okay, and we explain the so-called the so-called symmetry index. Okay, index of the symmetry location in the array. That means that you have two locations. So this one is the left end, this one is the right end. So these two are symmetry location. Okay. So this one is the one next to the left end, this one the one next to the right end. So these two are symmetry location. So this you swap, you will become reverse. Okay. Now next one we are going to talk about binary search. Okay, binary search. Binary search is to search number that already been sorted. Okay, already been sorted, and we would like to see if the number is in the array or not. Okay, this one we will use a different scheme. We'll use a different index scheme. So let's look at this one. So binary search is the idea that, okay, so when we do linear search, okay, when we do linear search, we have 3, 5, 10, 4, 2, 1, 11, okay? If we try to see if 7 is in there, we need to check the first number, second number, third number, fourth number, fifth number, sixth number, seventh number. So totally the compressor is order n, okay? You need to use the n time to finish, okay? And this take too much time. 10 minutes is order n. If we can sort the data, okay, if we can sort the data somehow, we have 1, 2, 3, 4, 5, 10, 11. Then we do not need to actually spend order n to sort for it. We can check the middle one. So right here, middle one will be 4. Okay, and 7 is bigger, so we search for the right side. Searching for the right side, then actually I check the middle one in the right side is 10. It's smaller, then I check the one on the left. So I check with 5 is bigger, so it's over here. Okay, so this one 7 is missing, but it just uses a 3 operation. I know it's missing. I know 7 is not in the list. So it actually is every time you divide by 2, so it's actually log n algorithm. So it actually is faster, okay? So it's faster, but it requires the data to be sorted from here to here, okay? So by the sorting, you need to pay the cost of n log n algorithm, okay? N log n algorithm. So actually, you need to pay the cost for sorting it. If you include in the cost, actually linear search is still be faster, okay? If you including the cost for doing sorting. Okay, anyway, right here, we do not compare the total compression. So we'll talk about how to do binary search. Okay, here we will try to explain how to do binary search. So now the algorithm of binary search is like this, okay? Before we continue to write the code, one thing I need to define is the midpoint, okay, midpoint. So midpoint, there are two systems, okay, there are two systems. So let's assume that there's a totally n number, okay, n number, okay, and this is from 0 to n, okay. So the midpoint is first way we actually do it, okay, it's from 0 to n minus 1. So first way to do it is that I just use n divided by 2. If I just do n divided by 2, say I have 4 numbers, right? 4 numbers. So 0, 1, 2, 3. So my n divided by 2 is actually 2. 2 actually would be this one, right? So basically, the midpoint, if your midpoint using n divided by 2 is actually 4 divided by 2, it will be the midpoint, but on the right side. Is included on the right side when it's actually even number. Okay, even number. If you have 3 elements, then n divided by 2 will be 1. So it actually is here. So n divided by 2 in odd number, it will be in the middle. Okay. Any question about this one? Any question about this one? Using the hop n to find the middle element. Is that okay?
Yeah.
Okay, so this is one system. Okay, you can find the middle point by this one, but the middle point find by hop n will be the middle point on the right hand side, the bigger side. Okay, the bigger side. How about another system? Another system you can use. Here you have a low set to 0. High is the last element. The last element you actually equals n minus 1. Okay, totally n element. Okay, so this one's low is the index for the first element. High is the last element. So we use these two to calculate the midpoint. So 0 plus n minus 1 divided by 2. Okay, so it actually is half of the n minus 1 divided by 2. So that is your midpoint. Okay, that's really midpoint. So let's assume that here we have 4 elements. 4 elements, you have 4 minus 1 divided by 2. It will become 3 minus 1 divided by 2. So it's actually 1. So 0, 1, 2, 3. Then the mid value will be this one. It will be the middle one, but on the smaller side. So it's different from the previous one that is mid value on the right hand side, on the bigger side. So if it is odd number we have 0, 1, 2, and then you have this one, it will be 3 minus 1 divided by 2 is 2 over 2 is actually 1. It actually still be in the middle one. So odd number is still be middle one. So even number, it will be the middle one, but the left hand side, smaller side. Okay. If you use a low and high system, and your b value is half of the low plus high. Is that okay? Is that okay so far? Any question? So we have two systems. Okay, we have two systems. First system, your mean value is calculated by length of the array divided by 2. In this case, even number of the element, it will be the middle value on the bigger side. Okay, or odd number, it will hit in the right middle. Okay. Second way, you do middle value equals low as an index for the first element plus high divided by 2. This one, the middle value would be the middle value on the smaller side. Or if it's odd number, it will be right in the middle. Okay? And these are two systems, and we are going to use this, okay, pretty soon. Any question? Damon, are you okay?
Yeah, I'm good.
Okay, so remember these are two systems for calculating the middle value. Now we are going to do binary search. So let's assume that we have a number, okay, a set of numbers. So here we have 1, 3, 7, 10, 15, or 17, okay? And then we have 19 and we have 20, okay? Let's assume that we have 8 elements, okay? And we are trying to see if 3 is in there or not. This 3 we call it key. We need to return the index of this key, okay? So the first thing is that our low set to the small index of the smallest one. So low initially set to 0. High set to the last element. So high is over here. High actually is 7. Okay, so you calculate the middle value. Middle value is actually half of the low plus high. So it's 0 plus 7 divided by 2. It actually is 3. So the first one we actually check would be middle here. So it's a middle one, but it's in the smaller side. Is that okay? So compare that one, and then apparently 3 is actually bigger, smaller. I'm sorry, smaller. Smaller than we will check 1, 3, 7. There are 3 elements, and we check 3. We hit. It's a middle value of R number element. So we hit, and you will return 1. Okay, so these 2 operations we find. Any question? Hello? Any question? Okay. Any question? No question? Okay, this one, no question. No question. This one, I'm going to ask question for people. Okay, no question means that you not participating. Okay, so next one, if I try to find, say 19. Okay, say 19. Okay, this one, James. Okay, James. Let me ask you, what would be the first number you would check if you try to search the key of 19 in binary search?
Would be the first number I want to check?
Yeah, which number you would the first one you would check?
The middle number.
Which one is the middle?
15.
Okay, you are not actually participating in the class, okay? We just explained it. We spend a lot of time to explain it. How to determine the middle value in binary search?
You do the low plus high divided by 2.
So what is low?
1.
Low is 0. Index of
Or 0.
What is high?
8. Or 7, sorry.
7 divided by 2.
So 3.
3. Which one?
The middle value is 10.
10. Okay, after that, what would be the next value you will search for?
Since it's lower than 19, you go up 1 index.
For which one go up 1 index?
You go up from 10, so you check 15 to see if it's equal to 19.
No. Not checking 7, 15, no. Second operation, you need to check this part. Okay, it's bigger, you check the right-hand side half. Okay, right-hand side half, you have 4 numbers. Which one will be the one you will check for the next one? So your low move from here to here, you actually go to here. Your low now is here. Because you know that it actually going to here. So your low value move to the one bigger than 10. Then what is the next one you will search or compare?
17.
17. How to determine it?
By doing low plus high divided by 2 again.
Okay, what is the low right now?
0.
Low right now is not 0.
So you're not reducing the size of the list?
We don't reduce. Yeah, it's the same array we use.
It's 4.
It's 4. And then what is high?
7.
7 divided by 2.
Yeah. So then 5.
5. Okay. So you will check this one. It's actually still be the middle one, but to the lower side. Okay, to the lower side. When you have even number of elements, our number is right in the middle. This one we explain it. Okay, please pay more attention.
Yeah,
to
I
the
was
class,
paying
okay?
attention.
Okay, pay more attention
wrong
to
in my head.
pay more attention to the class. At this moment, the only thing you need to do is pay attention to the class. If I say something wrong, you need to point out. Okay, pay more attention to the class. Okay, anyway, that's actually is 17, and 17 miss. So what happened? This one I need another person. Okay, this one Luke. Okay, Luke Ma. Okay, what will happen after 17 being a miss?
After 17's missed.
What will happen? What should you do?
Well, Well, if 17 isn't the right one, then it'll shift again. It'll search from index 6 to index 7.
So basically you're searching this portion now, right?
Yes.
So your low move to here, high move to here.
Yeah.
So what would be the next middle value now?
6 plus 7 over 2, so that's 6, index 6. So that corresponds to 19. So that'll have finished the algorithm.
Yeah, actually that's it. But you don't need to calculate. You always remember it's the lower half of the middle one. You have 2 number, you'll be the smaller one. Okay. 3 number, you will be right in the middle. It's actually the middle. 4 number, you will be the middle one, but actually it's the lower side. Okay. 5 number is right in the middle. Odd number, it will be right in the middle. Okay. 6 number, you will be 3 and 3. You will be the middle one to the lowest part. Okay. Always remember that. Okay. Always remember that. Using this low and high system. Okay. If you are using the n divided by 2 system, it's different. If your b value is actually being used, the length of the array divided by 2, then it's always the one on the right hand side. The middle one, if it's even number, say 8 of them, then you'll be the in the middle, but to the right hand side because 8 divided by 2. Okay, so this is middle 1, 2, 3, and 4 is over here. Okay, remember that. I'm calculating, teaching you the middle value for a while. Okay, I'm talking about it already. Okay, so that's the way you decide your middle value and actually finding the next one. Okay, so the binary search algorithm is something like that. Okay, you need to use that. It actually is use this one, low plus high divided by 2, taking the floor function. Okay, floor function for it. Okay, so that's actually the idea how you do the binary search. So we need to memorize this whole algorithm. Okay. We need to memorize this whole algorithm. So let's do this one called binary search. Okay, binary search. So here, let's assume that we have an array. Okay, here we have certain array. We sorted already. Okay, we sorted already. Now we are going to do binary search on this one. So here we have, and you will return some index value. Okay. And we have some key. We actually pass the key and we try to find the value for it. Okay, try to find the index for the key location. Okay. So this one, remember you have 2 numbers. One is called integer low. Okay, integer low will be 0. Okay, integer high will be equals data length minus 1. That actually is the last element's index. Okay, now here we have while. Okay, while low less than equals high. Okay, we do the following thing. Okay. Okay, so when low greater than when the exit condition, so when it go out of the loop, it means low greater than high. Okay. Okay, and this means that this really means that key is not in the array. The key is not in the array. So crossover, that means that key is not in the array. So say here, if we actually get started, this one we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements. So the first one we'll do is in the middle, that actually is 5. Okay, so 0, 1, 2, 3, 4, 5. We check 11 first. Okay, so let's assume that here we are trying to find 4. Okay, so we miss it, we do the left hand side, we compare with 5. If it's smaller, we'll compare with the left-hand side. We'll compare 1. Okay, 1 is the smaller of the 2. We miss it, we'll compare 3. 3 actually miss. And then after that, your low will be greater than high. So your 4 is over here. So you will cross over. Let's do it one more time. Okay, let's do it one more time. So here we have an index of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Let me see. I missed something. Here 1, 2, 3. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. Okay. 10, 11. Okay, this 11. Okay, so here that's okay. Let's redo it. Okay, so if I try to go forward, so my low is 0, my high is actually 11. Okay, so the first one I have 11, and then divide by 2 is 5. So I check the 11 first. Okay, and it means then my high moved to here. So my high actually right now is 4. Divide by 2, actually I get 5. So this one I compare 5. Still miss it. So then my high moved to actually 3. So my low is actually 1, my high is actually 3. So I check my 1 actually still miss it, so I move my low to 3, high also 3, and still miss it, it's bigger, so I move my low to 5 to index 2, and then my high is 3, so that creates crossover. So when low greater than high, and you will get out of the loop, it means that the data is not in the array. It just means that. So the exit condition is low greater than high. The data is not there. In this case, it's missing. You don't have that, so you return -1. Okay, you return -1. This one means that the data is not in there. Okay, now we have this one, and we will actually do what? Here we will do try to search for it. Okay, so we calculate the middle value. So middle value would be half of the low plus high. Okay, divided by 2. So please remember this version. Okay, you must remember a golden version, and then you know how to work on the problem. Okay, it's a golden version. So if this one is called key, okay, it will return the mid value. That is the heap. Okay. Else, if the actually A's, I'm sorry, this one should be mid value. Okay, mid value. So if the key actually is less than A's mid value, means that the middle value is bigger. Okay, key is on the left hand side. This one is on the left hand side, so your high should be equals your mid -1 to search the left hand side. Okay. Okay. Otherwise, you'll be on the right hand side. On the right hand side, your low should be equal your mid value +1. Okay. Okay. This one's binary search. Okay. Must remember it. Okay. Must remember it. Okay. This one you must remember it. Okay. Okay, this one you must remember it. In the exam, you'll see, okay, you'll see how it operates. Okay, so here we do system.out.print line. Okay. And then we do search. This is binary search. Okay, from array, and we search for 4. Okay, this one is searching for 4. So searching for 4, we are supposed to get -1. Okay, because it's not in there. Okay, so it's -1. Okay, this one is -1. Now let's search for something. Okay, we have. So let's searching for 19. Okay. So this one must remember it. Okay, this one is very important. This golden version, you must remember it, and also remember how to write it. Okay, you need to be able to write it right away. Okay, it's very important. It's just like your basic formula in math. Okay. So I'll post the code to you. Okay, that's actually binary search. We are review course, so we need to move on. Okay, we need to move on. So that's a binary search. Okay, one more thing I haven't covered. Okay, one more thing I haven't covered. Now, okay, let's assume that actually we do this, okay? We do this. We actually try to analyze, okay? So if we have 1,000 element, okay, 1,000 element, how many search needed to know that whether a certain key, say 255, is in the 1,000 element array or not? Worst case, how many operation needed? Okay. Okay, this question, let me actually for Katie, okay, Katie Wei, Katie. So if I have an array of 1,000 elements and I have a specific key called 255, how many times, we don't know about data, okay, it's okay, we don't know about that, but how many search will be needed for the worst case, maximum number of search needed for this using the binary search algorithm, assuming that the array already been sorted.
I'm not super sure.
You are not sure. So how to calculate it? No idea.
Not really. I just know that you had to like split it up into halves a bunch of times, but
that's not exactly half. Okay, so sometimes actually you have actually you hit the middle, but here you have 3 elements here, 4 elements here, right? So not even half, right? Not even half. Okay, this is the same question. Let me ask Oscar how to actually calculate the worst case performance.
You could like go through each set of divisions and then move into the one that has more elements in it if it's like not an even split.
Okay, good, okay. But here, let me teach you one way to do it, okay? Be careful, okay? Pay more attention. This one is very important, okay? This one is very important. Let's look at it, okay? So let's have a function called f function now, okay? F function. So fn, we are going to look at fn, okay? So that the worst, how many elements, f function is actually after n search, okay? How many elements being searched, okay? How many elements we can search, okay? Let's assume that we actually only one search, okay? So Oscar, actually one more question. Only one comparison, how many elements can you search for?
Wait, only one comparison?
One comparison, yes.
500?
No, one comparison you can only search for one element. You only compare yourself. Is that okay?
Yeah.
2 comparison, how many?
You're asking me again, or?
2 search, 2 comparison, how many elements can you search for?
2?
No. You calculate the mean value, right?
Yeah.
And then if we hit, it will return already, right?
Yeah.
If we hit, it will return already. Okay, let's assume that it doesn't hit. You will use the second search. Use the second search, you search the left side, that's one element you can search. Search for the right side, that's one element you can search. So this here it actually is 1 for the left, okay, and that actually is F1. Plus the middle one you compare, that's 1 you compare for the first search, and then 1 for the right, which is F1. Is that okay?
Yeah.
So this equation will become, okay, this is very important, okay? This actually I'm teaching you guys, okay? So it become 2 times F1 plus 1. Does that make sense? So you spend 2 comparison, basically you can check the middle one. Middle one doesn't hit, you check the left side. Left side, you spend 1 more search, you can only search for 1 element. You search for right hand side, you spend 1 more search, you can also search for 1 element. So totally 2 search, you can find 3 elements. Is that okay? You can search through whether the data is in there or not for 3 elements. Does that make sense?
Yeah.
Okay, now continue. Okay, let's continue. Okay, here actually I'm teaching you, not really testing you. Okay, so don't worry. Okay, so now the next one we actually try to find three elements, three tests. Okay, three tests. So the first test you check the middle value that you spend one search. Now you still have two search left. So you search your left side, you will be able to find F2 number of elements, right? Is that right?
Yeah.
Plus your middle one, plus your right side element that you can search. If it's bigger, you can search it. So here, this one is 2 times F2 plus 1. So it actually is 7. Okay?
Yeah.
Okay, now we've got a conclusion now. So the conclusion is very clear. Okay, the conclusion is very clear. The number of the element that you can search for using unsearch would be the function f we have here. Okay, this is the conclusion, very important. Okay, this one is f function is the number of elements we can search at after n compare. Okay. Okay, anyway, f1 equals 1. f2 equals 2 times f1 plus 1. f3 equals 2 times f2 plus 1 equals 2 times f1 plus 1 plus 1. Sorry. Equals 2 squared plus 2 plus 1. F4 will be equals 2 cubed plus 2 squared plus 2 plus 1. Is that okay? I asked her, is that okay?
Wait, could you repeat that last part that you did?
Let's do it one by one. Sorry. So the first one, F1 equals 1. Is that okay?
Yeah.
F2 equals this one. Is that okay?
Yeah.
F3 equals this one. So F3 equals 2F2 plus 1. Is that okay? So now we are going to put the 2F1 plus 1 to F2. Is that okay?
Yeah.
And F1 is 1. So it becomes this.
Yeah, that makes sense now.
Makes sense?
Yeah.
So F4 will be this one, and it's actually 2 to the power 4 minus 1. We can prove that. Is that okay?
Yeah.
So the conclusion is f of n search, you can search for 2 to the power n minus 1. Does that make sense?
Yeah.
Okay, now how to prove this one? Okay, how to prove this one? Okay. Anyway, before we move on, let me copy this one for you. Okay, copy this one for you. Let me make a copy. Okay, let me make a copy, and then let me actually post to the chat box. Okay, you need to download it. Okay, if you don't want to lose it, you need to download it. So this one we have many problems will depend on it. Okay, this one we would have many problems you need to depend on it. So this one I post it to the chat box. Okay, please download it. Okay, please download it. Now I'm going to clean it. Okay, I'm going to clean it. So here I'm going to clean it. One equation is okay. 2 to the power n minus 1 plus 2 to the power n minus 2. Okay, I'm sorry. Plus 2 to the power n minus 3 plus blah, 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 plus 2 plus 1. Okay, this whole thing will be 2 to the power n minus 1. Okay, how to prove this one? How to prove this one is you would have Sn minus 1 would be equals S minus 1, Sn minus 1 plus Sn minus 2 plus Sn minus 3 plus blah, 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 plus S plus 1. Is that okay for this one? Hello, is that okay for this one?
Yeah.
Yeah, and then you put the 2 to X, right? So 2 minus 1, it becomes 1. This whole thing becomes 1. So you got this equation here equal this one. Is that okay? Hello, is that okay?
Yeah.
Any question? Anyone has a question about this one? Hello, anyone has a question about this one?
No.
No, no question. Okay. Now go back to the question. Okay, go back to the question. The initial question I'm going to ask for. I'm sorry. So go back to the question. Initial question I'm asking for. So 1,000 element. How many search needed? Okay. So that actually really means that f of n, okay, equals 2 to the power n minus 1 would be greater equals 1,000, right? Right? Your number of search, that the element that you can cover by the number of search you have must be greater than this one, okay? So it's almost like, it's not exactly the same, but almost like this one, if this one is actually big N, okay, big N. So basically the number of search needed, small n would be equals big N plus 1, okay? Log 2 of the big N plus 1. Is that okay? Hello, is that okay?
Yeah.
Okay, it's almost like big log n, okay, and this almost equal to log 2n, okay, almost, okay, because this one, so 10 actually is this one 1,000 actually is a 9 point something, okay, if you take log 2, so actually we need 10 search to guarantee every element can be found in the array or not in the array, okay? Yeah, okay?
Yeah.
Okay, let's see. We have demo, okay? Okay, whatever. Demo, if you need to have question, you can call, okay? Call me. Okay, if you have question, you can call me, okay? Or call from whatever. Anyway, here I have a number. If you do need to say something, you can also call me. I can answer you, okay? If you lose your microphone, okay? Okay, anyway, we go back. Okay, so today this one is very important, no? Okay, we will see it many a time in the problem set. Okay, we'll see it many times in the problem set. Okay, but we need to move on. Okay, that's actually analysis of the binary search, and because we see many problems in the problem set, so we need to remember the F function. Okay, we need to remember. Next one is insertion sort. Okay, insertion sort you need to do. Insertion, okay, you need to sort it by doing insertion. So now let's actually directly go to the code, okay, directly talk to the code. So let's actually do insertion sort, okay. I'm going to directly call the code, write the code. So let's actually use the same example every time. So here I'm going to do import, okay, java.util.star, okay. So here I have stated okay, integer array a equals, okay, let's assume we have 5, 8, 1, 2, 4, 6, 10, 7, 3, and then 9. Okay, let's assume that this is an array we want to sort. Okay, so it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's the array we want to do sorting, okay? So public static, okay, void main string args, okay. Here we do system.out.print. I just set up the testing environment, okay. And every sorting will get the same. Here we will do system.out print line, print what array the toString of the array. So we actually print the array out, okay, and we will do sorting. So here we was sort A, okay, and we will do system.out print. We will print out this A array one more time, okay. So here I'm trying to show you how to do sorting one more time, okay. You need to remember the algorithm and memorize it, okay. You need to memorize it, also remember it, also being able to rewrite it by yourself, okay. So public, okay, here you need to do sorting, static function, you will return the array, and here you will do sort, okay, insertion. So this one is insertion sort, okay, insertion sort. So here you get an array A, and you are going to solve for it, okay, solve for it. So now let's look at what is insertion sort, okay. Let's assume that we have actually 3, 5, 1, 4, 2. We want to sort this algorithm using insertion sort, okay. Insertion sort, let's assume that actually the first element, initially let's assume that 3 is sorted, okay. 3 is sorted. To be inserted location is 5. So the data we want to insert to the sorted region is 5, okay. So we will back up 5 first. So 5 got back up, okay. And then we start to look into the sorted region. 3 actually is smaller than 5. So no shift. No shift. After the first sorting, we get 3, 5 is sorted. And then we got this one. Okay, so the first pass, we get this. Okay. Now, second one, we have the to be insert location is 1. So we back up the data 1. Okay, back up the data 1. 5 compared with 1 is out of order, so it's bigger, so we shift 5 to here. Okay, we shift 5 to here. Then we compare 1 to 3. Actually, 3 still out of order, so we put it over here. Okay, and then we actually put 1 in this location. So now 1, 3, 5 is sorted. Next one to be insert location, go to this number 4, okay? And 4, 5 out of order, so we shift 5 to there. And then 4 compared to 3, 4 is bigger. So basically we put 4 here. 1, 3 we copy. So 1, 3, 4, 5 sorted. Next one we compare with 2. Okay, to be insert locations here. And then 5 and 2 we compare. 5 need to shift. 4 need to shift. 3 need to shift. And then we do put 2 here. Okay. Okay, so to be insert location starting from 1 to the end of the array. That's the index for the outer loop. Okay. So here for integer I equals 0. I'm sorry, I equals 1. I less than a the length. Okay. I equals. This is outer loop. Okay, outer loop. Outer loop. Every time we find a to be insert element. Okay. So here I will write a note, okay. Index I is to be inserted, okay, to be inserted. Okay, so since that is data we want to insert it, so we will do this. The integer data will be equals the A's i's value will be the index data, okay. So here what we will do is, okay, what we will do is that we will insert it, okay. So we say, okay, integer j equals I minus 1, okay. J started from I minus 1, okay. J started from minus 1. So because we have 3, 5. 5 is the first to be insert location. So we start to compare the j value. So j go down, okay. So we have 3. Say we have 1, 3, 5, and we see 4. 4 is to be inserted location, so we start to compare this one. If it's bigger, we will shift. If it's bigger, we'll shift. If it's bigger, we'll shift. Okay. So that's the algorithm. So we started from I minus 1. The index that 1 smaller than to be insert location. And we start to use a while loop. A while loop, so but this j must be greater or equal 0. Okay? If it is less than 0, it actually is of no use. Okay, and also j need to be actually greater than the data. Okay? It is greater than the data. If it is greater than the data, then we will ship it. Okay, so now our a of the j plus 1 will be equals a of the j. We ship it to the right. Okay. Okay. After we finish that, we keep shifting. Okay. The j will stop at the what? Okay. Our j need to decrease. Okay. Here our j need to decrease. We search for next one. J need to decrease. Okay. So when we get out of a loop, if we do not have any element, we ship every element. So at the end, j would be be equals minus 1. Okay. Then here we need to compensate for 1. So j need to increase by 1. And eventually you have a of j. Okay. You need to put the data in there. Okay. That's it. This is insertion of sort. Okay. This one finish the insertion sort. Okay. This one finish the insertion sort. Okay. And let's run it. So remember how we actually do the sorting, okay? Any question on here? Okay, the outer loop I is to be insert location, okay? Here j is index for the sorted node. Okay, sorted nodes. But it is bigger, you shift to the right, bigger, you shift to the right, really, until you find a location that you will put your data in. Okay. But usually you will over deduct the j by 1. So you need to compensate it here. Okay. Okay, any questions so far? So this one is insertion sort. Okay, this one is insertion. So let's look at the slides one more time. Okay, so basically your 85 is your sorted location. The first to be insert location is 12. So actually 85 is bigger, so I shift to the right, 12 inserted here. So now 12 and the 85 are sorted. 59 is to be insert location, 85 is shift to the right, 12 is actually smaller, so I insert my 89 to here. Okay, so 12 no longer shifted. Next one to be 12, 59, 85 are sorted. To be insert location is 45. 85 bigger shift, 59 bigger shift. Okay, and then you put a 45 to this location. Okay, next one 72 is to be insert location, 85 shift, 59, okay, smaller, so you insert your 72 here. Next one, 51 to be inserted, 85 shift, 72 shift, 59 shift, okay, 51 inserted in this location. Any questions so far? Hello? So you must remember this diagram, that's one thing. Second is the call, okay, you must remember the call, okay, remember the call for insertion sort, okay. If you know question, let me know. Okay. Hi, Natasha, are you okay?
Yeah, I'm okay.
Okay. Now I'm going to upload the call. Okay. Please look at it if you do have question. Okay. Okay, we need to move on, right? So because today we have many algorithms need to cover. Okay, so I need to move on a little bit faster. Okay. Because I don't hear any response, I try to emphasize more time. make sure you understand it. Okay. Next one is selection sort. Okay, selection sort is different, a little bit different. Okay, it's not to be insert location. It's choosing the to be swap location. Okay? It's actually choosing to be swap location. You keep swapping. Okay, it's a swap-based algorithm. Okay. Okay. Anyway, let me actually write my own program. Okay. So next one is selections. So sensing I copy everything from the insertion sort. Okay. I copy everything from my insertion sort. And then put into my selection sort. Okay. Okay, I actually did not copy everything. I did not copy this portion. Okay. Okay, this one is a selection sort, but the setup is the same. Okay, setup is the same. Okay, here I need to actually do import. Okay, java.util.start. Okay, same thing here. You need to be able to sort it. Okay, so eventually we are going to return A array. Okay, but now we are going to sort it in a selection sort format. Okay, so what is a selection sort format? So first thing is you have 3, 5, 1, 4, 2. Okay. Okay, so 3 is the to be swapped location. We find the minimum here and we swap it. Okay, so after first one is 1, 5, 3, 4, 2. So the to be swapped location starting from here. Okay, the next one 5 is the to be swapped location. We actually find 2. Okay, and we swap it. Minimum is 2, so it becomes 1, 2, 3, 4, 5. Okay. Third one to be swapped location is 3. No one smaller than it, so no change. Third one actually is 1, 2, 3. We search for 4. No one smaller than the no search. Okay, and that's done. So to be swapped location starting from 0 to here. Okay, to the second largest number. Okay, so that's so-called selection sort. So here we do for integer I equal 0. Okay, I less than eta length minus 1. I increase. Okay. So this I is to be swapped location. Okay. Okay, we need to find the minimum. So integer, okay, min value should be equals A's I's value. Okay, you choose the color value as minimum. Okay, integer actually index should be equals I. You start it from there. For integer, okay, j equals I plus 1, okay, and then j less than eta length. Okay, j increase. Okay, so we go through the rest of the array to find if anyone is smaller than it. So if actually A's j's value is actually less than your mean value, okay, then we say minimum value would be equals A's j's value, okay, and then index should be equals j. Okay, when you get outside, okay, we already found the minimum value. So if the index, okay, not equals I, okay, not equals I. If it equals I, that means that you have no need to swap. Your I already is a minimum value. Okay, so here you do swap. So integer 10 equals A's I's value. Okay, and then A's I value, because your I location would be swapped with the index location. So it would be equals I's index location. Assigned to in A's index location would be equals 10. Okay, now you finish. This is so-called selection sort. Okay, this is so-called selection sort, and then we run it. Okay, we run it, and actually you get a same result. Okay, you get a same result. Any question on this one? Selection sort. Okay, the inner loop is to find the minimum from the rest of the array. Okay, I goes through all of the to be swapped location. Okay, so this one I'm going to post it as well. This one is called selection sort. Okay. Okay, next one we are going to talk about bubble sort. Okay, bubble sort. So bubble sort is the same thing. We are going to go bubble sort. This different sorting is tested in AP. Okay, so remember it's very important. Later we'll review the problem. Okay, now I'm going to go over the bubble sort. Bubble sort is also called a sinking sort. Okay, it's also called sinking sort. Okay, must remember the sorting algorithm I give you. Okay, you need to be able to rewrite it by yourself. Okay, this one is a bubble sort. Also, so that's actually it's also a swap-based sorting. So 3, 5, 1, 4, 2. So we compare, not out of order, so no swap. We compare these two out of order, so we swap. Okay, we compare these two out of order, so we swap. We compare these two out of order, so we swap. So after the first rotation, you get this one. Okay, and 5 is the heaviest location. So it's sink to the bottom of the ocean. Okay, after that, this one is actually sorted. Sorted. After that, we are looking at this portion. Okay, so we compare out of order with swap. We compare these two, not out of order, no swap. Compare these two, out of order with swap. So the second round, 4 is the heaviest location. So this 4 and 5 got sorted already. So next one we have 1, 3, 2. Okay, 4, 5 sorted. We compare no swap. We compare swap. So 1, 2, 3. So now 3 is actually considered to be heaviest one and sorted. Now the next one we compare these two, no swap. So 2 considered to be sorted. So everything is sorted. So the last element starting from the last one down to the first one. Okay. So that's the bubble sort. So you need to remember this. Okay, when you remember the algorithm, say for integer I equals a dot length, okay, minus 1, I greater than 0, I down to 1, okay, and I decrease. Okay. So here, I is the heaviest point. Okay. Okay, now, and then for integer j starting from 0, okay, is starting from 0. So here, say you do, say your heavier location right now is the last one, okay. So you do starting from 0, 1, 2, 3, 4, okay. So you compare 2 value over here, 2 value over here, 2 value over here, until the last one, okay, until the last one. So basically j from 0, okay, and j less than I, okay, and j increase. Every time you are j, okay, so j is the small leading index for the pair for comparison. Now, if A's J's value is actually bigger than, okay, bigger than A's J plus 1 value, okay, then you need to swap. Okay, you need to swap. So we do swap if it is out of order. Okay, so here integer temp equals A's J's value. So here is again is rotational swap. Okay. H j will be equals H j plus 1. Okay, H j plus 1 will be equals 10. Okay, that's it. We finish the bubble sort. Okay, we finish the bubble sort. Okay, that's it. And then we run it. Okay, we get a same result. Okay, we get a same result. Let me close the window to prove that this is the same result. Okay, let's run one more time. Okay, you get the same result. Any question? Okay, so this one bubble so keeps swapping. Okay, keep swapping. But sometimes you may optimize this one. Okay, you may optimize this one. Okay, so here you actually here. Okay, here you may actually have a boolean. Okay, a value need pass. Okay, need pass. Need sorted. Okay, need sorted. So this sorting is actually set it to be true. Okay, and here this one and okay. Actually here we will have need sorting. Okay, if we need sorting, we will continue. Okay, and here we will set this sorting to be false. Okay, so every time we assuming that there's need sorting to be false, this is extra version. Okay, with this sorting is extra version because we want to save time. Okay, sometimes the array already sorted. And then if you never do swap, okay, if you never do swap for the whole pass, that means you no longer need to be sorted, okay. But here, actually, if you do some swapping, we will say the array still need to be sorted. So we will turn on the need sorting when there's some swap in certain pass. Then the next pass, you continue to swap, okay, continue to compare and swap. But this one still get the same result. It just be faster, okay? It just be faster. So I give you a multiply enhanced version of the bubble sort, okay? Next one, let's actually go to the merge sort, okay? Merge sort. Okay, let's go to the merge sort, okay? Merge sort, you need to do divide and conquer, okay? You need to do divide and conquer. Okay, merge sort, you need to do divide and conquer. Okay, do divide and conquer. So here we have a number. Okay, you have a number. So we divide that into two halves. Okay, two halves, and then you need to sort the first half and you sort the second half and then merge them back. So the first half you divide into two again, and you need to sort the first half and divide and sort the second half. And you will merge them again. So and then you do split it into the two halves for the two elements, and you need to sort them back. So you split until it's actually one element, and you do merge. Okay. So this one is called merge sort. So it's a split. 7 elements you divide into 4 and 3. Okay, 4 and 3, and then you okay. And then the 4 you split into 2, 3 you split into 2, 1, okay, and 2 you split into 2, 1, 1, okay, and then you merge back, okay, something like that. So first things that we need to write the merge algorithm first, okay. So here I'm going to write another one called merge sort, okay, merge sort, okay, merge sort. So I'm going to write merge sort, but before we write the merge sort, let me copy something from the bubble sort. Okay. Okay, let me copy this thing to the bubble sort. So array is still the same. Okay, array is still the same. Let's still copy this one over. Okay, so here I'm going to do experiment. Okay, so here I'm going to create a array of b. Okay, which is 1, 3, 1, 3, 5, 7, 9. Okay, and we would have another array. Okay, that's called C, which is even number 2, 4, 6, 8, 10. Okay, we need to merge these two array. Before we do merge, so we need to know how to do merging. Okay, merging the two array. And BC are used for merging array only. Okay, it is used for merging array. So here, let's do this one. Public. Okay, static. Okay. So, Okay, system.out, system.out. Okay. So we are going to merge these two arrays, okay? Merge B array and C array together. Okay. So here we are going to go for topic, okay, stated. Okay. I'm sorry, I need to upload the bubble sort to you. Okay, selection sort finish. Let me upload the bubble sort script. So we can take a look on the algorithm. Okay. Any questions so far? So here we are merging two arrays together. Okay, so merge. Okay, and we have a array and have a B array. We need to merge these two arrays together. Okay, so let's assume that we are merging two arrays together. So we have one array. Okay, now let's actually call this A as data. Okay? A as data, and here let's call this one A array and B array. So we are going to merge A array and B array, okay, together. So actually, you have A array and B array. So the way we merge it is we have A array, R number 1, 3, 5, 7, 9. B array we have 2, 4, 6, 8, 10. Okay. So here we use a rounding index P pointing to index 0. We have rounding index Q pointing to the index 0. Okay. So we have another rounding index pointing to a C array here. Okay. So we compare the A array's element and B array's element. If A array element is smaller, we copy that into C array. And then my R advance to the next one. My P also advance to the next one. Now I have 3 compared with 2. 2 is smaller, I copy to array C, okay, and my R advance and my Q advance to 4. Now I compare 3 and 4, and actually this time actually 3 is smaller. 3 is smaller, so 3 copy to the array. So my R advance, my P also advance, okay? Something like that until actually the array finish, okay? So right here, I need to create a new array. That array is my result array. Let me call it C, okay? At the very end, I need to return that array. And this C array would be equals new integer element of A length, okay, plus B length, okay? So that actually is combined length of the two arrays, okay, and copy the C, okay? And then we want to copy from these two arrays to it, okay? So file, okay, file actually, so we need to have the 3 rounding index P equals 0. We can do P equals Q equals R equals 0, okay? No, it doesn't actually, it doesn't allow this, okay? So P equals 0, Q equals 0. Okay, okay. So now we finish this one. Okay, we finish this one. So we do file, okay. P less than A length, okay. That means the P array not been A array not all been traversed yet, okay. So Q actually Q less than B length, okay. So both of them we haven't finished, okay. Comparison. We actually will keep doing this, okay. So if A's P's value actually is smaller than B's Q's value, or small equal to, then we'll do the following. We'll do C's R increase, okay, only that would be equals A's, okay, P increase, okay. Else, okay, C's R increase will be equals B's Q increase. So this one is copy the smaller one from either A array to C array or from B array to C array, okay. And we will get out of here, okay. So we get out here, and one of the P or one of the A array or B array may not be finished yet. So we need to copy the whole thing from there. Okay, and then to the C array. Okay, this one finished the merging. Okay, this one finished the merging. You need to remember the whole object. Okay, so system out three arrays that two string the A array. Okay, we copy this one and we two string B array. Okay, and then we do have integer array C equals merge of A and B. And we print out C, okay? Okay, so merge algorithm. So this says you must remember, okay? You must remember and also be able to rewrite it yourself, okay? You must be able to rewrite it yourself. Okay, done. And let's see if it successfully merging the data, okay? Okay, you have 1, 2, 3, 4, 1, 4, 3, 5, 7, 9, okay? If this one, you actually merging the data, okay? Any question about this merge algorithm? Hello, any question? This is partial result, but I still want to pass to you. Make sure if you have any question, you can ask right away, okay? Any questions so far?
Can you explain really quick again what the last two while loops do?
These two?
Yeah.
These two happen in this way, okay? These two happen in this way. Let's actually look at some data, unbalanced data, some unbalanced data. So maybe you have 1, 9, 10, 11, okay? Merging is 2, 3, 4, 5. Is that okay? So this one is A array, this one is B array. This is really unbalanced, okay? So now you have a C array, So your P pointing to here, right? Q pointing to here, your R pointing to here. So number one, your 1 is smaller, so you copy to here. So your R going to 1, your P going to 1, okay? So you compare these two. Now this one, 2 and 9, 2 is smaller, so I copy 2 to here. So R going to 2, actually Q going to 2. So now 3 actually is smaller, so 3 going to here, Q going to 3. I'm sorry, this one is 0, 1, this is 1, this is 2, okay? So here this one going to 3, okay? And then here 4 is smaller, so we copy to here and going to 4. And this one going to 3, okay? 5 is smaller, you copy to here. And then you go in here, okay? And this one actually get out of bound, so here your BQ equals B dot S. So actually B already all copy, but A still have 9, 10, 11 there, right? Is that okay?
Yeah.
In that case, this guy will copy the whole thing after it. Does that make sense?
Oh, okay. Yeah, got it. Thank you.
So vice versa, if this one work only when A is longer, and actually second one work only when B is longer. Does that make sense?
Yeah, so it just takes whatever's like left over, right?
Yes. Good question, actually. This one is a very good question. Any other question? Hello, any other question?
Yes, in the diagram you showed just now, the arrays A and B were the same length, but after merging, no, wait. Yeah, how come the array C had five elements?
Can you repeat your question?
Oh, yes. How come C has 5 elements when A and B only had 4? In the example you showed just now.
In the example I have here is a 5 element in A, 5 element in B. So C is 10 element.
Oh no, no, I understand this. It's just the example you talked about in the last question asked.
Yes. And what? Yeah.
Okay.
So that's question. Okay, that means we show the last questions example. So we have 1 and then 9, 10, 11, right? That's
Yes.
the one I'm using. So what? So what is the question? So you have C actually is 8.
8, yes. 8
Yeah, eight.
slots.
So you copy the 1 here, copy the 2 here, copy the 3 here, 4 here, 5 here, and then it's actually the length is A plus B.
Okay.
So you finish B. When you finish B, A still has 3 elements. So copy this over. You okay?
Oh.
Copy this whole thing over to here using this while loop. Is okay?
Yeah.
Does that make sense?
Yes.
Yeah, the box I draw is too small. Sorry. Yeah.
Yeah, got it. Thank
The
you.
box that I draw is too small. Sorry for that. Yeah. Any more question? So this merging is very important. Okay. Merging by itself is an important algorithm. Okay. So this one is actually what? This one is actually what? Merging from small to large. Okay. Small, actually small to large. Yeah. Large to small, you actually need A and B both sorted. So the precondition is that both A and B must be sorted. Okay. Must be sorted. Now we want to do the data. Okay? We want to sort this data. We want to write the merge sort. Okay. So public. Okay. Integer. This one will be merge sort. Okay. Merge sort will still be a recursive function. So we got a array. So here this array, let's assume that is data. Okay, so call it D. Okay, call it D. Okay, data. We want to process an array D. Okay, and we will do sorting. Okay, now let's assume this. Okay, if actually D the length is actually less than 2. Okay, 1 element or no element, then you just return it. There is no need to sort it. Is that okay? Is that okay? If it's only 1 element or 0 element, 0 or 1 element, no need to sort it. Okay. Now we actually, let's assume that we have 4 elements now. Okay. Actually we have 4 elements. So 4 elements you need to divide by 2. Okay. So first half and second half. So it's 0, 1, 2, 3. We use the same index system as binary search. Okay, so you just need to remember one system. So right here, let's actually calculate the low. Okay, so integer low equals 0. Integer high equals D the length minus 1. Okay, integer mid will be equals low plus high divided by 2. So this index system is the same as what? The same as the binary search. So this one, 4 value, the mid value is the middle one, but in the lower side. Is that okay so far? Hello, is that okay?
Yeah, that's okay.
Now we are going to split it into 2 halves. We're going to split it into 2 halves. So I'm going to split it into 2 halves. So I have an integer array, first half. First half, how many elements? Your mean value is calculated is here, right? So the first half, the number of elements should be mid plus 1. Okay, so it should be mid plus 1. So here, new integer mid plus 1. Is that okay? Hello, is that okay? Second half, how many elements? Half 2 is new. How many elements? It actually is D the length minus mid plus 1. Is that okay? Okay, you actually can don't do mid plus 1, use minus the A the length, H1 the length. Your total original data minus the first half length is your second half length. Is that okay? Hello, is that okay?
Yep.
So you calculate the mean value, and the number of elements for the first half is the mean value plus 1. Okay, it's 2. Okay, mean value plus 1. So that's your first half is here. Okay, second half is the total data minus the first half length. Okay, finish that we are going to copy. Finish that we are going to copy the first half and second half from the original data. Okay, so that's actually have a rounding index called p. Okay, so integer p equals 0. We are going to use this index. Okay, so for integer I equals 0, I less than h1 dot length and I equals. Okay, and my actually my h1's i's value will be equals my data's p plus plus value. Is that okay? Then for integer I equals 0, I less than second half's length, I increase. My second half's i's value will be equals my d's p plus plus value. Is that okay? Hello, is that okay? So this one, these two follow basic copy your first half to H1. Copy your second half to H2. After that, you create a new array. This new array, let's call it integer C array will be equals, I'm sorry, okay. I'm sorry, no, not yet, okay. So you'll do merge sort, okay. Actually, your H1 will be equal merge sort of H1. So H1 go to sorting and then you will return, okay. H2 will also go to merge sort by itself and you'll return H2, okay. And eventually these two array you will merge together to C, so merge your H1 and H2 to C, okay. And at the end you return your C. Any question? That's merge sort. You divide it into two halves. You sort in the first half, you sort in the second half, and you merge back. And this is a recursive function, but it works, okay? Any question?
This isn't about this method in particular, but this is merge sort. Then what was the last method again?
The previous method?
Yeah.
You say this one?
Yes.
This is merge function.
Oh. Okay.
Merge function is that here you sort the first half, you sort the second half. You need to merge the two.
Oh
back.
yeah. Now they. Oh, I see.
It makes sense?
Yeah. Okay.
That's why I explained the merge first.
Okay. Yeah. Thank you.
Yeah, no problem. Okay, no problem. You're welcome. So now we actually merge things back. Now we need to print it, right? Print it. We actually get it from the bubble sort. Okay. So copy this one, sorting, put back to here. Okay. Okay, so here we actually should have integer, okay, array. This one is what? It's called data. Okay, so data. So let's actually put data equals merge sort of the data, and we print out our data. Okay, and then before that we print out system.out that print line. So data before sorting. Okay. Okay, we actually print out the data before sorting. Okay, so here this second one is actually merge sort. Okay. Okay, this one merge sort. Is that okay? Sorted. not really long. I have very compact version. Any question about multi-source here? Let me upload to you as well. Okay. Remember this, every single algorithm, you need to remember them. Okay. Just like the way I memorize, you need to be able to rewrite it. Even if you go to college, they still require you to write it. Okay. Even if you go to college, you will still rewrite it. Okay. Any question? Any question? Okay. No question. Let's do this. Okay. Right now it's 7:41. Let's have a 9 minutes break. Wait until 7:50, and we come back. Okay. For the parents' problem set. Is that okay? To put this knowledge into there, but during the break, if you have time, okay, if you have time, please, and you still don't understand, please check my algorithm, okay? Every single one. I give you all of the algorithm that you needed, okay? Is that okay? Read it, okay? You will need that, okay? You need that. Okay, break to 7:50. Hello, any questions so far? No question? Okay, no question. First, I want to talk about, okay? Today we learned a few algorithms, right? And I ask you to remember them, okay? I ask you to remember. So is that necessary that you always remember a lot of algorithms when you do computer science? Is that true or no? Actually, it's true, okay? Just like you play piano, do you see anybody who is actually pianist, and when he play piano and he cannot remember the melody, and he still need to check certain book back and forth in order to be able to play it. Okay, you should not see any pianist doing that on the stage to perform, right? So that actually knowing the algorithm and being able to memorize all of them is actually a fundamental training for computer science student. Not only that you are able to memorize them, but you also need to be able to reshape it in certain application in certain way. You must be able to adjust the algorithm sometime. Okay, so that's actually is a fundamental training. So the way I told you that, okay, go over the insertion. So you need to remember it, remember that, remember that. Okay, that's the way I remember how insertion so been done. Okay, so after 30 years, 40 years, I still would be able to remember it. When did I learn this insertion sort? It's actually in my college, okay? In my college freshman course, C language programming, we learn sorting at that time. Same sorting algorithm, 30 something year, almost 35, 36 years, still the same sorting algorithm, never change, okay? So something like that, you still need to remember everything you learn, okay? When you do coding competition or you actually go to certain job, they don't have time to allow you to go to check internet and somebody wrote it before. It's not something like that. Okay, you need to be able to generate it right away. So a good programmer is also a good code generator. Okay, you must be able to generate the code just like you are a machine in the competition in very short time to generate a big volume of code, okay? So that is good programmer need to do that. Not only memorize it, but you actually also need to have the capability to generate in the short time, okay? If you consider computer science as a job, that actually is something you need to do, okay? Okay, let's actually go back, okay? We will work on the first problem, okay? So this time, let me start from the back, okay? William Tsai, okay? William How about the first problem? What is the answer? William, hear me?
Oh, hello. Sorry, I was
Oh,
muted.
yes.
I think it's E.
That is an easy, okay, everyone. Second one, we have William, okay. I don't know your last name. I don't see. So second problem, okay. Okay, this one, let me upload the problem set, okay. Let me upload the problem set first. Some of you may not see the whole problem. So let me upload the problem. Actually, it's downloadable from our Moodle site, okay. You should be able to download it every week. But here, for your convenience, I upload it one more time, okay. Okay, I finished uploading, so you can download if you need it, okay. So here, problem 2. Problem 2, actually, this one is sequential search. So what is the Boolean condition need to be there? Which one?
E.
E?
D for dog.
D for dog, okay. Okay, whatever. D for dog, okay, D for dog. How to actually determine it? Here is one while condition. So while A condition, you do that, okay. So when you get out of the loop, what condition you should have? If here you have A condition, when you get out of the loop, what condition you have?
That I is equal to n.
I equals to n, that's one possibility, yes. So I equals n or what? Or what will happen?
Wait, can you repeat that?
When you get out of while, what condition you should have? I equals 1 is one possibility. What other condition you should have? May have.
That the value has been found.
Value, how value put into mathematical format?
That the value is not equal to a index I.
No. When you get out of loop, that's not that. Value being fine, and you say value not equals a of I. Value being fine, you say a not equal, then it's not fine.
I don't get what you're trying to ask.
When you get out of while loop, what condition you need to have? So why you pick D then?
Because I has to be less than n to loop through the entire thing, and then the value has to go until the value is found.
Value is found. So what do you say value is found in math? Value is found actually is value equals A's I, isn't it? Right? Is that right?
Yeah.
Yeah. Equals I, that is found. If it's not equal I, is not found. So that's the thing you need to know. You get out of the loop, you need to have that condition. So right here you have A condition. So out of the loop, you are pretty sure it's A bar. Not A should be there. Because if you are A, you're still in here. You get out, it's not A. Is that okay? Not A must be true. So get out, you will actually A actually equal 0. Okay, A equals 0, A equals n. Okay, A equals n or value equals this. Okay. Okay, so A bar is this. Okay, see this one is when you actually try to solve this problem, A bar equals I equals n or value equals A of I, right? This whole thing is bar, this whole thing is A bar. So A will be equals I less than N, okay? And value not equals A of I using the so-called De Morgan theorem, okay? Using the so-called De Morgan theorem, okay? So that's why we actually pick the D, okay? That's why we pick the D. Is that okay? So testing this one, okay, you need to know about when you will get out of loop. So you will guarantee the condition over here, okay? Need to study it to the detail, okay? Okay, so one, let me have Oscar, okay?
Yeah.
So one thing is that whenever you get out of while loop, very likely, okay, it must be sure. When you get out of while loop, at this point here, A bar must be true. That's for sure, okay? Because when you are still in A, you're still in the loop, you never get out. You get out means that A bar is true, okay? Or not A is true, okay? That's a pretty simple condition you need to know. Okay, that's count number 3.
Would it be E?
Okay, the feature of, okay, you need to what? Necessary by the search the feature, which is feature of the actually the order of the data. See, you must be sorted. Let's see, a better useful, better say. Sequential, you don't need that. Is that okay? Binary must be sorted. So the answer is C. Okay. Okay, number 4. Number 4, let me have Natasha. Okay. Number 4. Okay, here you have the sorted array and unsorted array. So which algorithm sorted array is actually better, faster? That's the question. So you should say number 1 is one sorted array faster. And Natasha, is one sorted array faster? Yes or no?
No.
No, because why? Because you have 1, 3, 5, 7, 9. If you want to insert a 4 here, you need to shift everything and then put a 4 there, right?
Mhm.
Unsorted, you can directly put to the end. So basically insertion, no. Insertion is no, okay? Insertion is no. Deletion is also no. So actually here, number 1, no. How about 2? Searching for a given element, yes or no?
Yes.
Yes, this one you have binary search in LB, yes. Number 3, computing the mean value.
No.
This one equal, right? So
Yeah.
no, equals to no. So here you only have B, okay, good job, okay. Okay, number 5, let me have Luke, okay, Luke Mark, okay. An algorithm searching for large data set, okay, then for a specific value X, compare every third element. Okay, so this one is like, you compare every third element. So here you have a large data set. You compare third element, third element, third element, third element. Okay. And then okay, until you find it's greater than. So there's a greater than, you start. Okay. Okay, and then you found that value, and then you locally search for the path to find the value. Okay, this one, if you actually jump by 3, you search for it, you can reduce the algorithm by an order of 3. Okay, but there's a certain actually it still be order of n by 3. Okay. But this one, if you want to beat the binary search, what nature need to have?
Let's see.
If you want to beat the binary search, what nature you need to have?
Well, probably C.
Why C? It will be better.
Well, if X is close to the beginning, then ideally it should only take one. Yes, one search.
One search you can.
Iteration.
Okay, good. Number 6. Let me see. We have look. Okay. So next one I have Katie. Okay, Katie, number 6.
Is it E?
Yeah, you already say that it's greater than everybody else. Okay. So number 6 is actually E. Yes, you already say it's greater than everybody. Number 7. Let me have James. James Lee. Well, okay. Again here, actually, right here, if you get out of here, it actually is what? You already know that A of the index will be equals key, okay? Will be equals key. You already do that. So definitely fail means that this never happened. Okay, so what does that mean?
So E.
No,
Or
definitely fail.
it fails.
Yeah, definitely fail. This was a fail. This is not successful.
So fails, then
Fail means you never have this.
yeah, so it's the key is never equal to A at index.
What does that mean?
When key is not in the array.
Yeah, not in the array. And actually the index will get out of bound. So you have array index out of bound problem and key is not in the array. Is that okay?
Yeah.
Okay, good. Next one, we have Henry, okay? So here we do have a sorter, there's a swap, whatever. There's a selection sort, okay? Selection sort. Then we do swap, okay? Whatever, this is a selection sort. I think that is the same as the selection sort we have. So sorting from big one to small one. So up to 3 paths, which one it is? Same algorithm we have. It's almost the same. You check it, it will be the same. So up to 3 paths, what will be the result of the 3 paths?
Is it A?
Okay, so let's work on this one by one. Okay, you have 89, 42, minus 3, 13, 109, 70, and then 2. What would be the result of the first pass?
109, 89, 42, negative 3, 13, 72.
109 and then
109 and then 42.
42. So the first pass you swap 89 and 109, right?
Yeah.
Second pass
109, 89, negative 3, 13, 42, 72.
Who swap with who?
89 and 42.
Okay. Okay, yes. Third pass, who swap with who?
Negative 3 and 70.
Okay, so you get the answer that would be A. Okay. This one is number 8. Okay. Number 9. Number 9 is a search function. Okay, it's a search function, and then assuming the method work as intended. Okay, what would be the precondition it need to be? This one, actually, let me see. Wait, Henry. And then we finish Henry, right? Next one, Eric U, okay, Eric. Hi, Eric. Hear me?
Yeah, I'm here. I'm just opening the file on my end.
This one is a searching algorithm, right? Searching algorithm. How to work on this problem?
Is the answer E?
How to work on this problem? How to determine how to work on this problem? Anyone know how to look at this problem? Anyone? Okay, Aska, do you know how to look at this problem?
What do you mean by how to look at this problem? What do you mean by how to look at this problem?
How to solve this problem?
Oh, you would have to like look at how it works and then try and figure out what the requirement is.
And if you don't know how it works,
oh, then I'm not sure if you don't know how it works. Like
how could you know that it works, right? That's a problem.
I know it says assuming it works as intended. It says assuming it works as intended.
It's work intended, so how do you know that it works?
What do you like? You would look through the code and see like what
you look at the code, and then what is the how can you determine which one is the correct answer?
Like you would look at the while condition, and then
you look at the while condition, and then
like it says index is less than v dot length, and then if index is less than key, so that means that v has to be sorted already.
Yeah, that's a key. Here you have the order, right? You have the order. If the you are comparing the order, you are trying to find someone who is bigger than you. If the data is not sorted by this way, right? And you saw someone big, say you saw someone bigger than you, and you stop, right? There may be someone still smaller than you that may meet. Okay, so who knows? So that won't work. So the fundamental idea is that the data must be monotonously or increasing, right? Or something that is not strictly increasing, but almost always increasing. So a certain region, you'll be able to find the answer. So that the key, you must be sorted. Is that okay? Otherwise, you cannot say that, okay, a certain value smaller than you, you can get out. You can continue. If it's greater or equal than you, you will get out. Okay? You cannot say that because you may still have smaller value later. Then it doesn't work. Does that make sense? Hello? Does that make sense? That's why I asked, how do you look at this problem? You look at this problem because that if you know that it requires you to have such things monotonously increasing, then you pick A that actually is a reasonable answer. Okay, but the problem is that if you are not sorted, your data may be like this. Okay, since your data like this, so what's the reason why you compare the index and key? Making no sense because you make a trap over here. You make a trap over here. You never get the right data because you always have smaller or even bigger data afterward. So you cannot say that I find someone bigger than me that I get out. or equal, then so what? It doesn't make sense. Is that okay? Hello? Is that okay?
Yeah, that's okay.
It doesn't make sense. So this actually is to teach you how to look at the problem. That's the key I ask for, okay? How to look at problem, how you answer the problem, okay? So the next one is a binary search, okay? This is a group of a problem. So let me copy the number up, okay? Copy the numbers up. So 4, 7, 9, 11, 20, 24, 30, 41, okay? So here we are doing practice. So my question always is how to solve a problem, okay? I always ask related problem. So here we have binary search, okay? This one, demo, okay? Demo win, okay? Are you okay? Hear me? If you hear me and you still cannot talk, you type, okay? But next time, please check your microphone, okay? Can you talk? Please talk. So next time if you come to class, please check your microphone, okay? You still don't have? So, okay, so here you do typing, okay? So find the key value, okay, after the first pass, okay, which portion you need to search for. If your key is 27, okay, so which portion you need to search for? Please type your answer, okay? You have a key of 27, and up to the first pass, which portion you should search for? Why C? So what is the mean value you check for? Which mean value you calculate? Okay. Okay, next time, make sure your microphone is working, okay? Next one, okay. How many iterations needed to determine 27 is not in the list, okay? This one will go back to William Zhai, okay? Here the data is over here, okay? Here with our data is over here. So how many iterations needed to determine 27 is not in there? So William, which is the first one you check? Is A data, which one is the first one you check? Hi, William, you hear me? Hello? Hear me? Okay. Hi, William Zhai, you hear me? Are you there? Okay, next William. Okay, we have another William. Okay, another William. What's the first number you will check? We have A number.
11.
11. How to determine?
Low plus high divided by 2.
Is there a faster way to determine it?
Just the middle number, but you go down one.
Middle number go down one is a smaller one on the middle two, okay? Even number you go to here. So what is the second number you check?
Well, 24.
How to determine it?
You do the same thing just for the larger side.
Smaller side. This portion, but the middle one, yeah, you mean the right side, yeah, is the right side. You check the right side, yeah, check the right side, but the middle value is on the lower half, okay? Okay, and then you still miss it, and then what happened?
And
then you should search for what?
27.
No, you 27 compared to 24, you miss, and then what will you do? Next step.
go to 30.
30. Now you actually you need to check data for 30 and 41. Which value you check?
30. I don't
30.
know.
30, yeah, 30 is the right one. And then what happened? $27 is smaller. Smaller is
Yeah.
over here. No data to search. You cross over. So how many tests so far?
3.
3 tests. B. Okay. So you need to be quick on this. So the rule I told you, cut into half. Try to find the middle one, but it's on the lower side. It's very important. Why is that? It's actually very fast. Compare you do, okay, calculating this is 0 plus 7 divided by 2. That's wasting time. Is that okay? Hello?
Yeah.
Okay. That's why I spend time. But you need to be careful, okay? Right here, we use the middle value using low plus high divided by 2. But sometimes it will be cheating on you. You're actually using the n divided by 2. Then in that case, you need to be careful. It's actually the middle one, but on the right side. Is that okay? Hello? Is that okay?
Yeah.
Be careful. You need to verify the algorithm is the same with us. Then you can use the algorithm we use, okay? Okay, so what will be the result for this one? We have binary search of 4. Okay, this one for Oscar. What's the result? So 4 is 1, index what?
That should be D. Oh, yeah, D.
It's 0, right?
Yeah.
Okay. So let me copy the data one more time, okay? Okay, this one actually, okay, this one actually is very difficult, okay? Hi, Natasha, okay. Here, if the test for the while loop change to this, okay, no, originally is low less than equals high. Now it changed to low less than high. Originally is less than equals high. Now it changed to this, okay? So which one you cannot reach? Why? Why you cannot reach that one? So how to solve this problem?
Is it 11?
No, not 11. How to solve this problem? The while loop only have this low less than high, not low less than equal high. How to solve this problem? So anyone know how to solve this problem? Anyone? Hello, anyone? When you read this, how you translate it to certain way you can solve the problem quickly. When you read this one, how do you translate to solve the problem quickly? Okay. Luke, do you know?
1 sec. Right. While loop. Well,
So what does this tell you? When will it stop? When will the algorithm stop?
oh, yeah, when the search reaches the center of the array, so the midpoint, but the issue is it's got 8 elements, so okay, there's a trick here. Just give me a second.
Okay, okay, it's okay. You can keep thinking, okay? Would you know? Let me know. How about Henry? Do you know? Would you read this one? What's the key point? How to how to solve this problem? The program will stop when this one A condition, right? I told you in the class, the program start when not A happen, right? So not A means that low greater equals high. Okay, originally it's low less than equals high, and then the not condition would be low greater than high. So there's a crossover. When there's a crossover of low and high, you stop. But right now it's not crossover, you would stop. It will be low greater or equals high, you will stop. What does this really mean to us?
I hate to interrupt, but I think I just got it.
Yeah, what does this mean to us?
Well, it's if the array corners is searching for a value that's all the way on the right side of the array. So let's say in this case it's 41. It'll keep searching until it's cornered at index position 7. In that case, low and high will be equal to the same number. So it'll break, and yeah, in that case, well, 41 isn't on here, so we'll have to assume the opposite end of the spectrum, 4.
Not a corner issue. Actually, it's not a corner issue. It actually will stop when 2 are equal. Okay, when 2 are equal. When 2 are equal.
Yeah, that's when.
So what does it mean by 2 are equal? Low and high equal means what?
Meaning that the array, it's only got one position left to search since.
Yeah. When 2 equal, it means that it's only one element to search. Okay, so let's check. Okay, let's check. If it is 11, when you search, okay, when you search, they are still A elements, so not 11. Okay, not 11 is not the answer. When you search 7, there are still 3 to search, so not 7. When you are searching 24, there's still 4 elements to search, so not 4. Okay, when you search 4, it's only one element. Okay, if you search 9, it's only one element. Okay, when you search 20, it's only one element. Okay, when you search 30, there's still 2 elements, so it's not this one. So you search 31, it's still one element. So the one I write down with 1, they are all possible answers. But here it only has 4. Okay? Does that make sense?
Yes.
Okay, so I teach you how to look at the problem. Okay, I don't expect you to tell me A, B, C, D, E. Okay, A, B, C, D, E, we can look at the book solution. So why we actually just know the answer? Key point is that if you search originally, if you down to 1, you will continue to compare, and then you will get out of loop when there's a crossover, right? Now it doesn't start at crossover; it starts at equal sign when it down to only one element. So which location it will be down to only one element? You look at starting from top level 11 for sure not, because it's the middle of everybody. 7 is not. It's the middle of the left 3. 24 is not. It's the middle of the left right 4. 30 is not. It's the middle of the right 2. Okay. Other than that, 4, 9, 20, and 31, they all will be searched down to the long element. Is that okay? Does that make sense?
Yes.
Okay. So that's the way you solve the problem. Okay. We try to teach you the way to solve the problem. We actually want you to try, okay? Try to contribute the idea. We don't care about A, B, C, D, E, okay? That's not the important part. The next one, Oxcar, okay? For binary search, which of the following assertion will be true when every iteration of the while loop? So you're still in the loop. When you're still in the loop, what does it mean? You are in the loop. What will be true when you're still in the while loop? That's what he said.
Wait, for binary search,
when you're still in the while loop of the binary search, what will you have?
B. That's B.
B. B means that the keys between low and high.
Yeah.
No, it actually is E. Either you will hit it or you will miss it for the next time, or the data is not there. So this one actually is telling nothing, but that's the condition you have for each iteration. When you are still in the loop, means that you may hit it or you may miss it, or the data even not be there. So this one, when you get out of the loop, it's very sure you actually have key not in the array. Okay. When you are still in the loop, you may have these three conditions. They're all possible. Is that okay? Number 15, let me have Natasha. Okay. How to solve this problem. Number 15. Actually, this one I talked in the class. Okay. Natasha, are you okay?
Yeah. Give me a second. Is it C?
No. How to solve it? We talk about the problem. This one is you need to use the F number for N search. Fn is what? Remember that?
I don't remember.
We talk about F1 equals 1, right?
Yeah.
F2 equals what?
Is it 2 to the
No,
one?
2 times F1 plus 1. Okay, you need to, after class, you need to look at it, okay?
Okay.
It's actually using two search, how many number you can reach. So one search in the middle, you may go right or go left. Each one is one more search. Okay, so F3 will be 2 times F2 plus 1, okay? So Fn is 2 to the power n minus 1. This number need to be greater or equal to 30k. So n equals 15a, okay? We must pay attention to the class, okay? We are talking about important, useful stuff, right? Otherwise, you spend a lot of time still don't know how to solve it. Any question on this one? Hello, is that okay? Another is that okay?
Yeah, it's okay.
You need to get understand this, okay? If you
Okay.
don't understand after class, you must watch it one more time, okay?
Okay.
Okay, next one, let me have look, okay? So look, what is this one? Actually, is this one is an insertion sort, okay? Insertion sort from large one to small one, okay? Surpass after insertion sort. So that has 17954 chirp, okay?
Insertion.
So first, after first, actually first iteration, first pass, what will happen? This one is to be insert location, okay? After first pass, how will happen? Initially, is from big one to small one, okay?
Right.
So after first pass, what will be the result?
The first pass.
You need to do 3 pass, right?
Yeah.
So you must
Oh,
have the first pass and then second pass and third pass. Hey, look at the screen. We actually do not need to type keyboard, right? This one you just, if you know how to the answer, you really actually do not. If you know the way to look at it, you actually don't need to touch keyboard at all.
so the 1 is inserted to between 7 and 9.
Yeah. So first one, you pick the 7, you one shift to here, so it's something like this. How about second pass?
Okay. Second pass. That's
What will happen after second pass?
Since 9 is bigger than 1, it'll get shut. They'll get switched.
And then
same thing for 5. It'll get switched again. So
no. Second pass. I only need second pass.
Oh, second pass is 7, 9, 1, and so on.
No. After the second pass is not 7, 9, 1. Okay, you must spend time, you must focus on the class. Okay, we talked about this already. Second pass to be insert location is 9. You ship the data. Normal algorithm is actually a big one ship, but this one is from bigger one to smaller one. So small one ship. So 1 and 7 ship, your 9 will be inserted in this location.
Oh.
So this one is sorted up to here. So now third pass, after third pass,
5 is switched with 1. Yeah.
So third pass is right ship. 7 and 9 with 1 ship. So 9, 7, this one. So the answer is B. Okay. Okay, so you must remember the call and also remember each pass what happened. Okay. Otherwise, you are not able to solve the problem for sorting and searching. Okay. Must remember. Okay, next one, let me have KD, okay? Number 17. I'm teaching you how to solve the problem. So I need to tell you how to prepare for it, okay? So KD, how to solve the number 17? Not only tell you this is A, B, C, D, okay? Telling you A, B, C, D, we just need to copy the answer to you. We do not need to spend time to discuss it, right?
I think it's B because 9 and 5, those are already in order.
And then?
Yeah, and then all I have to do is switch the 1.
Okay, so here, if I have this one, if I have this one, how many sheets I will have? From big to small, how many sheets I have? So basically, this one will be ship. So there's totally it's just 5 sheets, right? Is okay? It's almost sorted. So the second portion actually is sorted, right? So every time the first part you ship this one, second part you ship this one, third part you ship this one. So totally 5 sheets, right? Is okay?
Yeah.
Okay, look at this one. This one you only have 3 sheets. So you actually counting how many out of order pair. So if it's closer to the shifting condition, it should be that. So this one's B. Based on all of the order pair. Okay, based on all order pair. So this one, let me have James. Okay, James, how about number 18? This one big to small. Which one need to change position the most? So the one most unsorted or reverse order, right? Which one?
Would it be E?
No. This one is actually sorting from big to small. Which one is most small to 1? Reverse one. The 18 would be A.
Oh.
A is almost all reverse except for 5.
Yeah.
Is that okay?
So probably A.
Everybody's order need to shift because eventually you need to have 9, 7, 6, 5, 4. So everybody almost need to be reversed. Okay. So you count the number of out of order pair. Okay. So next one, let me see. Have Henry. Okay. Henry number 19. Okay. How to solve this problem? Again.
Well,
so,
first thing I noticed is like the second one is definitely correct. So.
Yeah. Now here actually what? Here actually I don't care whether it's correct or not correct. Okay. Here actually what's the change for this one? You originally have it say greater equal 0, but now you don't. What will happen? In the insertion so what will happen? What does it really mean?
Well, isn't that just to like prevent so in the while loop you're doing j minus minus, so it's to prevent that from going below 0, right?
No. If we don't have this one, if we don't have this one and it still work, what does that mean?
If you don't have it and it still works?
It still work. Yeah, what does that mean?
That means that A0 is always larger than the others?
Not always bigger than other. It's actually the first element never been shipped out of the box. Okay. Yeah, it's actually the largest one. Okay.
Yeah.
So actually 1 and 2 are true. The first element never shipped out of it. Okay. It also is there. It never been shipped out of it. Okay.
Yeah.
So this one is D1 and 2. Okay. Number 20. This one. Let me have Eric U. Okay, Eric. So the element in the long list of integer are roughly sorted. Okay. So 5% need to be sorted. Okay. And then which is the very reason why insertion sort is is used rather than selection sort. Okay. So number one, is there fewer comparison needed for insertion sort or not? Is that true?
I don't think so.
Fewer comparison, you are almost sorted. I would say this one actually is yes. This one number 21 is actually yes. 1 is yes. You have fewer comparison. Selection, so you need to compare everybody to get the maximum or minimum. You need to traverse through the whole array many times. So selection, so spend a lot of time on comparison. So this one is true. Okay. Second one, fewer position change. Is that true or not true for insertion sort?
That is true. It's true.
No, this one is not true. Okay. This one is not true because selection sort every time you compare, you find a maximum and you swap. You compare, you find a maximum, you swap. So totally there is only n swap needed. But your shifting maybe, your insertions of shifting maybe, here you shift 5 elements, this time shift 3 elements, this time shift 5 elements. So there are more shifting in insertion sort than selection sort. So 2 is wrong. Does that make sense? Hello, does that make sense?
Yeah, makes sense.
How about 3? Is that true or wrong?
I think it's not true.
Why not true?
I'm not exactly sure.
Yeah, then how can you pick that's not true? Anybody know why? What happened to the number 3? How much space needed for insertion sort and selection sort? Anybody know? How about William? Zai, do you know? William, are you there? Number 3. How much space requirement for selection sort and insertion sort?
I'm not too sure the difference between the two. Sorry.
You don't know about the difference?
No.
The answer is the two are equal. Both are using one array, so what? It's the same. They're always the same.
Okay.
Yeah? Is that true? Right? What I'm talking about is true. So you
Yeah,
must be decisive, knowing that whether it's the same or wrong or not, okay? Don't just have a vague idea of what it is, okay? So this one is the what? This one is also wrong, okay? Because the two need the same amount of space. A, okay? Okay, not a problem, okay? Here we are practicing, but I just need you to participate more, okay? Everybody to participate more. Because we are discussing, we need to learn how to solve a problem. Number 21, let me have, let's see, let me have, go back to William, okay? Another William. Why merge sort is a better sorting than insertion sort? What is the very reason why merge sort is a better sort than insertion sort for sorting long and randomly ordered list? Okay, what is the reason? William, is one true or not? Merge sort require less call? Yes or no? Hello, hear me? Is one true or not wrong? Okay, let me choose another person. Oscar, do you know is one true or not? Merge code require less code. What?
Not true.
Not true, it's wrong. Okay, merge sort need more code. Second, merge sort require less space. Yes or no?
No.
Also wrong. Okay, so you probably ready to pick C already. Okay, this was an easy problem. Okay, number 22. Okay, number 22. Okay. Number 22, let me have Natasha. Okay, what does this really means? What does the number 22 really means? What are they asking for?
They're asking for what is the most efficient way to search for PQRS.
And which one? Which one and why? Yeah.
Is it D?
Why?
Because you're searching the first letter, which is P, and then to make sure it's that sequence, you have to check the
No, that's not the purpose. Okay.
Okay.
What happened is like you only check every fourth letter. Okay. So 0, 1, 2, 3, you only check this one, right? You only check this one. So there may be a PQRS. So a certain location say, here you may have a PQRS, you have a Q over here. You may have a S over here. Okay? You may have a P over here. You may have an R over here. Okay, so as long as you check every 4 of them, you find one of the PQRS later. That means this point is worthy to say, to look at its neighborhood. And they might be a PQRS format. Is okay? If every 4 of them you check is not PQRS, then don't worry. Nearby there's no PQRS for sure. Is that okay?
Yeah.
Yeah. So that's the fundamental reason why this will work. Okay. So D is checked because if you find it, there's one of the PQRS element. That means based on whatever PQRS, you can check its neighborhood to check if it's a complete match or not. Okay?
Okay.
Does that make sense?
Yeah.
So D, okay, 24 is D, 32 is D. 23, let me have look, okay? Look more. Let me see. So there are 10,000 string, so you can use binary search under what condition? There's only one condition for binary search. What's that?
A.
No, there's only one condition for binary search. What's that?
D. It has to be in there.
No, it must be sorted.
Oh, then C.
C is okay. Always remember your binary search always need to be sorted before you can use. Number 24, okay, number 24. What algorithm is this one? This one we have Katie, okay, what's this one? So is that sorting or searching first?
I think it's searching.
It must be searching because sorting must be longer, so it should never be sorting. So which one?
I think it's sequential search.
Yeah, it must be sequential because binary you must have a low, high, and left and right. Okay, so there's no such thing. But 25 actually you don't need to work on it. It's a quick solve. Okay, so let's bypass it. 26. Okay, 26. Let me have James. Okay. A merge sort will be used to sort array, okay, in increasing order. What's the purpose of merge function? James?
Let me see.
Merge function.
It's the divide and conquer one, right?
Merge function is combining two array into one.
To sort them into increasing order, like it says.
No.
Or it splits them up.
Merge function. We are not talking about merge sort function. We talk about merge function.
Merge function.
Mm-hmm. Okay, pay more attention to the class.
Is
okay?
it B?
No, it's actually you need to merge the two array into a sorted array. It's actually D, okay?
Yeah.
You have the A array and B array is sorted into a C array, merged into a C array, okay? Merge function is different from the merge sort function, okay? Pay more attention. 27, let me have Henry, okay? 27. 600 number, how many search needed?
It's B.
B? Okay, how to determine it?
2 to the n minus 1 is greater than 600, and so
Yeah,
2 to the n is greater than 601, so the answer is 2 to the 10.
9 would be n is equals 9 is 512. Okay. And then 10 would be 1024. Okay, so actually it's
Yeah.
between these two. So you need to have 10. Okay, good job. But it's good you remember the equation, okay? That is very, very important. Next one, 28. Okay, 28. Let me have Eric U. Okay, Eric. A worst case situation for insertion sort would be what would make an insertion sort work? Which one is the worst case?
I think number 2.
Reverse order. Okay, that's a pick, easy pick. Okay. Number 29. Let's go back to William Zai. Okay, William. So consider binary search algorithm to search for order list of numbers. Which of the following choice is closest to maximum number of times such algorithm is Q? The main.
The B.
Okay, 1 million. 1 million is what? How to solve it?
I think it's because it's binary search. 2 to the 20th is the closest to 1 million.
Yeah, it is greater than, okay?
Yeah.
Okay, so actually 20. Yes, good job. 30. Okay, 30. Okay, number 30. Let me go back to William. Okay, I'm sorry. Another William, okay? Number 30. How to solve this problem? We are almost there, okay? 3 more problems after 30. Hello, hear me? Do you hear me? Hi, William, you hear me? Okay, this one, let me pick the Oscar, okay?
I haven't finished it yet. I haven't finished it yet. I just need to look at it for a minute.
Yeah. It's okay. I just need to know that you are there, okay?
Okay.
So how to solve this problem?
You just look at like how each of these works.
Okay, so how would be the complexity, right? So how is the complexity of sequential sort? How much time needed?
Log n.
Order n. Okay.
Oh, n, sorry.
Binary search
log n, I think.
is order of log n, okay? Insertion sort.
n.
No, it's order of n squared.
Oh, okay.
So you have 1, 2, 3. Should be 2 less than 1 less than 3. Is okay?
Okay.
Which one? A, right?
Yeah.
Okay, let's look at the 31, okay? 31, let me have Natasha, okay? 31, let me have Natasha. Okay, 31. 31 is a high-low game, okay? High-low game means that, okay, I ask you to answer a number from 1 to 100. You say 84. I have some random number, or I have already have some number in my mind. So for example, 54, okay? You say 84, I say lower. You say 20, I say higher, okay, something like that. So this one is very similar to the binary search, okay? So basically, suppose that the game is supposed to use a binary search strategy, okay? What is the minimum number of the guess the computer, maximum number of the guess computer to make before using guessing user's number? So there are 100 number. How many guess needed, Natasha? Using binary search. How many?
E.
No. How to solve it this way? 100 less than equal 2 to the power n minus 1. So what is the n? Right? Is that right? How many? And Natasha, how many for this? Two to the power n minus 1 greater than 100. What is the minimum n needed?
7.
7, okay, 7. But 2 to the power 1 to 2 to the power 16, you all need to remember. Is that okay?
Okay.
Then you'll be faster. In the test, you'll be faster. Okay, if you use a sequential search, okay, how will be the maximum number of guesses needed? Okay, this one for loop, okay. Which one? Which one? Sequential search. you have 100 number to look at. How many maximum search needed?
Well, it's a sequential search, so
Yeah.
99.
Why 99? Why not 100?
Well, if assuming the correct answer is at the end, it'll have to make 99 guesses before making the correct guess.
You make the correct guess, then you still need to have 100 guess, right? So if you do this, if you do for integer I equals 0, I less than 100, I plus plus, right? You do if A of I equals key. How many comparison you need to have? This one is 100 comparison.
Oh.
But definitely not using this way. If it is this way, you will actually end up with 100. Okay?
Okay.
So my challenge to you is that why you know it's 99?
Well, like I said, it's probably just the way I'm interpreting the question, because it says
how you interpreted the question. That's my question.
Well, it says what's the max number of guesses computers could make before guessing the user's number. So I'm assuming that means wrong guesses. So it can make a maximum of 99 wrong guesses before making one right guess.
No, it is you compare, right? But down to the last test, you always said yes or no. When you say yes is here, no is here. So the comparison only 99 of them would be enough.
Oh.
Okay.
All right, 100 then.
Does that make sense?
Yeah.
Okay, anyway, number 31, okay, then 31, let me have James. 33, I'm sorry. Average for sequential search. Hello, James. Hear me?
Yeah.
Which one? This actually asking you the sequential search. On the average, how many search needed? Best case 1, worst case 99, right? And then average.
Yeah. Average would be between 51 and 99?
No, it's 50, okay? We are talking about
average. Okay.
Okay? Okay, this one you must remember is at half of the N, okay? Okay, thank you very much. Any more question on any test or anything? If you don't have question, you can be dismissed. If you have other question that in the test or in the practice set or anything related to AP, ComSci A, you can stay and I'll answer you any question, okay? So if you don't have question, you can be dismissed. Any question? Okay, anybody has any question? Okay, if you have any question, just say it, okay? Say your name and I have some question, like any question, I'll answer you. We are approaching the exam, okay? So please do more practice and then I'll try to help you, okay? Okay, Oscar, any question?
No.
No? Okay, thank you. How about William, do you have any question? Okay, no questions. Thank you. Good night then. Good night. Bye-bye.
Thank you.
Bye-bye.